Hello students, good morning. I hope you're enjoying it home, right? Okay. So we'll start with chemical bonding. Last time we started with chemical bonding, right? Okay. Yes, I was telling you like we'll do questions, right? Very important. Because I think theory part too, I think you know, right? So there's no point of doing the theory part again and again, right? We'll do questions only. So questions that also we have discussed in the Zoom sessions, right? So it will not be difficult for you. Fine. So we'll discuss some, questions only, right? Okay, so first, last time I discussed NO, right? Okay, now let me tell you, like, how will you draw N2O molecule? Okay, suppose in exam they ask you, okay, how to draw N2O molecule. Fine, so you draw like this, dot structure. I'm telling about dot structure, right? Okay, N2O. Now, students, you'll ask me a question, right? Listen carefully. That said, you are drawing N and O. Why can't you draw N O N? Somebody will ask like this. Fine. The reason is experimentally NN bond. If you draw a triple bond, it will be stronger, student. I'll just rub this. Okay. So if you get a triple bond between nitrogen, it is going to be very strong. Okay. One more reason is experimentally this is the what is observed. N and O. Fine. Okay. Let us draw the dot diagram now. Let us draw the dot diagram. Correct. Now 1 minute. 1 minute. So experimentally you get like this N and O, right? Now you show the dot diagram. Dot, dot, dot. Correct? Cross, cross, cross. Correct? Now student, nitrogen has got how many valence, right? You will see only the valence, right? 5, na? 5. Correct? Okay. Now here also you draw 5. Okay. Oxygen has got 6 valence electrons. Fine. Now just look at this diagram. You look at this diagram. What you should do is when you are drawing this dot, we have explained in theory also, you should not have more than 8. Not more than 8. Now just check this nitrogen atom. Does it have more than 8? 6 plus 2, 8. So here you see octet is complete, right? Okay. Now let us check this nitrogen also. Same thing, 6 plus 2, 8. So octet is complete. Let us check this oxygen also. Again 6 plus 2, 8. So again octet is complete, right? Okay. But students, here you see one peculiar bond here. This bond is called coordinate bond. Like we have discussed this. What is this coordinate bond? The nitrogen will share its pair of electrons. Remember, nitrogen has like this 5. So actually, I should draw like this. So nitrogen is sharing its lone pair with oxygen. So you are getting a coordinate bond, right? Okay. So what will be the actual structure? So you see, I am able to draw a triple bond for nitrogen. So the answer will be N. Okay. Fine. Just see NO. So you are able to draw a triple bond, right? Okay. Between two nitrogen. This will be the structure of N2O. Fine. Students, you can draw some other structures also. Okay, we'll see that later. But this will be the structure of N2O. Now suppose this structure is drawn to you, just see very carefully. Exam they can ask you how many lone pair of electrons, please concentrate here. How many lone pairs are present in the whole molecule? Okay, whole molecule has got how many lone pairs? Let us see what are the lone pairs here. You see this is a lone pair, I'll use a different color. Okay, I'll use a different color here. See, this is a lone pair. Can you see this? This is a lone pair, this is a lone pair, this is a lone pair. Suppose in exam they ask you how many lone pairs are there. The answer is there are 4 lone pairs. Okay, so there are 4 lone pairs, right? Fine. That will be the logic of this. Okay. So student, that is how you draw N2O. And there are so exam, they'll ask you how many lone pairs, right? Fine. So then that's how you draw the dot diagrams, right? So I think you will get a lot of practice in that. Okay. Like let us draw for carbon monoxide. Suppose you want to draw for carbon monoxide. Okay. Fine. Carbon monoxide. Clear? Fine. Now just see here. So carbon has how many valence electrons, Joanne? 4. Oxygen has got 6, right? Okay. So now I want to draw the structure, right? Carbon, O, fine. So you see I have shown 4 electrons per carbon, right? And oxygen has got 6. Okay. Now students, if you try to draw a coordinate bond, I'm sorry. Okay. Now see this very carefully, this structure. Just see. Surrounding carbon, do you have octet? Yes. Oxygen also you have got octet, but there is a coordinate bond here. Can you see this coordinate bond? Okay. Oxygen is sharing its lone pair with carbon. So what will be the structure of this? Dot, dot. Okay. This is the structure of it. Clear? That's how you draw. So you get a coordinate bond. So this coordinate bond helps you a lot. So you're using a lone pair to form a bond, right? Okay. That's how you draw carbon monoxide. It has got 2 lone pairs. This is one lone pair, right? This is one lone pair. Fine. Okay. So that's how you draw the dot structures, please. Very, very important. Okay. Now, so you know how to draw a dot. We'll do one thing. We'll take directly, some structures, right? Where we'll see what is a hybridization, what is the shape, and all that. Now, before that, I will just draw you one table. This table will be highly helpful for you. What first thing is, student, you should know. Okay, I'll write down. Student, you should know number of bond pairs. That is nothing but BP, right? Plus number of lone pairs, right? Now, before I say bond pairs, we are going to talk of sigma bond pairs only. Sigma bond pairs. Okay, this is sigma bond pairs plus number of lone pairs. We'll say LP. Okay, suppose the number is A, sigma bond pair, right? And A. Fine. Now, if this number A is 2, we can write the hybridization. Yes, tell me what will be the hybridization if this number is 2? SP. Fine. If this number is 3, okay. If this number is 4. So, students, we have done this in theory also. If this number is 5, what will be the hybridization? SP3D. 6. Okay, fine. So, very simple, you can know the hybridization. Now, SP, what will be the bond angle? Next thing, student, you should know the bond angle. Make this table. Please copy down this table. This table will be highly helpful for you. So, I'll do one thing. A, right? So, I will tell you the bond angle. Okay. Now, for SP student, you will get bond angle 180. Okay. SP2, how much will you get? 120. Okay. For SP3, the bond angle will slightly change depending on number of lone pairs. So, you can say for SP3, this, clear? See, no lone pairs, 0 lone pair, 1 lone pair, 2 lone pairs. Make this table shown to be highly helpful. 0 lone pairs, what will you get the angle? 109.5. 1 lone pair, 107. 2 lone pairs, 104, 104.5. Right? And also remember the example. The example for this is beryllium chloride. The example for SP2 is SO3. Okay, fine. So make a table like this. It will be highly helpful for your exam. If you remember this table, I think you have studied everything. Methane, ammonia, water. And next thing, student, you should know the shape also. Okay. I think I will better. I'll do one thing, student. Better I'll draw the shape here because this is more having more space, right? What is it? Linear. Okay. Sorry, I have to draw it up. So make this table. What will be the this thing? For 120 triangular. Clear? Now for this you will get three shapes. 109.5, what will you get? Tetrahedral. So students, if you make this table and just by heart this table, this chapter is almost done. 50% of the chapter is done. Just by heart this table. Okay? Of course, don't carry this into your exam, like clear. Just by heart it. Methane. I'm talking of methane. 109.5 tetrahedral. One lone pair. What is the shape? One lone pair? Pyramidal. two lone pairs. Okay. Please students copy this table. This table is 50% of the chapter in this table only. If you know this table, you know 50% of the chapter. Okay. Now I'll do this in the next slide. First, can you do this? Okay. Just copy this. So let us come to 5 now. Hybridization. Then, uh, but remember, depending on the lone pairs and all, hybridization will be what? sp3d. Okay. Then, shape. Before we come to shape, let us see number of, okay, let us write bond angle. Now sp3d, student, you have 5. So if all the 5 are bond pairs, when I say BP means bond pair, please remember BP is bond pair, right? Okay. And what is LP? P is lone pair. Okay, BP is, we can just, okay, fine. 5 bond pairs. Shape will be, take more space for shape. Five bond pairs. Okay. What will be the angles one? You know, remember? Trigonal, bipyramidal you will get. So what are the bond angles? 90, 180 and 120, right? Correct? Shape. Short form you can call TBP also, right? Okay. K is equal to 5 bond pairs, right? Now student, you can get 4 bond pairs and 1 lone pair. Again the angle will be same only, but small difference will come in the angle. Okay, because of their repulsion. Okay. Yes. 90, 181. Where will you preserve? Where will you put the lone pair? Lone pair should be in the equatorial. Correct? Lone pair in the equatorial. Lone pair will take more space. So what will be the shape? Come on, tell me. Seesaw. Okay. Okay, fine, no problem. Next. 3 bond pairs, right? What is the shape you will say? T shape, right? Again you place the lone pairs in the equatorial. Okay. Yes. What are the bond angles you will get? Now again you will get the same bond angles. 90, 180, right? But please remember here, you will get only 90, 180 you will get for the lone pairs, right? But as far as bond angles are concerned, you will get only, okay, bond angle is concerned, you will get T shape, na? So you will get only 90 degree. Okay? Lone pair will come here, student, lone pair will come here. So you will get this angle, right? Fine. You get 90, slightly less than 90. Okay? Are you clear? Why that slightly less than 90? Because of that repulsion. Lone pair repulsion. Okay? Fine. And we'll write examples also. But let's take the next one now. Two bond pairs and three lone pairs, right? Okay? Yes. Bond angle will be correct, linear. Fine. Now, let us write examples also. PCL 5. Okay? PCL 5. For this is SF4. Four bonds, right? And you know how to calculate bond pairs and all that, right? Four bonds and one lone pair, right? For this CLF3. For this I gave an example I3 minus. Can you remember? So students, please copy this table. This table is very helpful. I3 minus, please remember. There is a minus sign here. Okay. Right? Now let us come to A is equal to 6. Let's come to A is equal to 6. Yes. What is the hybridization? Very good. Then shape. Before I come to shape, angle. Okay. Let's take this now. So all six are bond pairs, students. What will be the angle? Exactly 90. Okay. Shape octahedral. Okay. All six are bond pairs. 90 octahedral. Example, I think you know this example, right? SF6. Then four bond pairs. Okay, let me take five bond pairs first, right? Five bond pairs and one. This is six bond pairs. Okay. Six bond pairs, 90 degree of. Now five bond pairs and one lone pair. You can give an example as, you know, just check it up. Sulfur will have six. Bromine will have how much? Five bond pairs. You get one lone pair. Shape will be square pyramidal, right? Angle also you will get slightly less than 90, slightly less than 90 because of that repulsion. Okay. Then you can have students four bond pairs and two lone pairs, right? Okay. Yes, you can write like that. Yes. LP means lone pair. Again, you will not get exactly 90, less than little bit less than 90, right? And you will place the lone pairs in opposite. So slightly less than 90. Again repulsion, right? This is obviously going to be square. The best example is okay. Four bond pairs, right? Okay, students. So please note down. This is about sp3d2. The last one, student, is 7. Of course, 7, they don't ask much. The best example for this is IF7, right? The shape is pentagonal. Bipyramidal, right? Students, here you will get angles 72, 90 and 180. Now you are going to get 72, just see. You are going to draw a pentagon. So this is your I. F, F, okay. So there are 5 F's here, right? So 72, 72, 72, 72, 72, right? Okay. So everywhere you will get 72, right? Because 72, 360, right? 360 divided by 5. So how much will you get? 72. Okay. Fine. And obviously you will get two flowing atoms here and here. Okay. Let me rub this. Clear? 5 plus 6, 7. Axial. These are two axial bonds. You have got equatorial bonds, right? Pentagonal bigram. Okay. Fine, students. So this is how you will pentagonal 5 and then bipyramidal 2 to 7, right? Okay. So this hence the whole hybridization and all those things, right? One last thing, student, you should know how to calculate pi bonds. Very important. This is what we have been discussing in a lot of detail. Suppose I give you SO3. Oxygen has a tendency to form double bonds. Please remember. Oxygen has always got that tendency. Out of this, one is sigma, one is pi. Here also one is sigma, one is pi. Here also one is sigma and one is pi. Okay. The question they will ask you in exam is how are these pi bonds formed? Okay. See here, what is the hybridization? sp2. What is the angle? 120. Correct. And please remember, sulfur has d orbitals. Please remember, very very important. So don't forget that sulfur has got d orbitals. Okay. So sulfur la வந்து sp2, but sulfur has d orbitals. Okay. So sp2 means student, how are these 5 bonds? sp2 na எவ்வளவு p orbital இருக்கு? There are 3 p orbitals, right? px, py and pz. Am I right or wrong? px, py, pz. Out of that, 2 have been used. So one is still left over. One is still left over. Okay. That one leftover p orbital student will be for use for forming pi bonds. Okay, for pi bond, please know, for pi bond, no hybridization. No hybridization. Okay, so one p orbital is still left. So that can be used for hybridization. So then this pi bond will be formed by how? P pi, p orbital of sulfur with a p orbital of oxygen. Because oxygen doesn't have d orbital anyway. Clear? Let me repeat, one p orbital is still left. Okay. What about the other two? The other two will be, this will be d pi, other two will be formed from d orbital only. There is no other chance. Okay. Clear? Even this pi bond, how will be formed by d pi p pi? Okay. So you get one p pi p pi and two d pi p pi. Right? So Shwan, you should know how to know whether it's p pi or, and the order of strength is p pi bond is stronger compared to d pi p pi. Okay. And there is one more type of bond d pi also. But this is the strength of the bond. P pi will be the strongest actually. Okay. Just note down this, just note down this. Correct? So, and now the reason why is d orbital like weaker in pi bonds? Why? Because see, p orbital is directional. Can you see this p orbitals right? They are highly directional orbitals. D is something like this, like, okay, let me draw it. This is d orbital, right? And this is your p orbital. Okay. Now, if you see p orbital overlap, pi bond, right? This is my nucleus and all that, right? Okay. If you see this p orbital, right? Pi bond, okay, it is a little bit directional. Whereas d, if I draw a d orbital and d orbital, like overlap, right? Or let me show it another way. Okay, now see here. Pi bond will be formed by what? I'll use a different color here. Between this and this, correct? See this and see this, right? Okay, not that strong. Similarly, you can get a bond between this. I'll use a different color here. Clear? Can you see d orbital overlapping? Okay, it will take, it's something like this. The distance, if you see the distance between this lobe and this lobe, if you see, is very high. Can you see the distance? This lobe and this lobe, very high. Whereas in p orbital, if you see very carefully, student, just observe this p orbital. Okay, just observe, see the distance, see the overlap, very strong. Can you see that? Very strong overlap. ரொம்ப தூரம் இருக்கு இந்த லோபோ this lobe and this lobe, students, they are very far away. Okay, they are spread out. Okay, that's why d orbital, students, is called diffuse. In fact, I'll tell you one interesting thing. Why is it called d orbital? Okay, because it is diffuse. Diffuse means what? Spread over. Clear? You see the distance between the lobes very, very far away. Here, if you see, it's very close. So P pi is always going to be stronger, student. Always stronger. Okay, compared to D pi. So distance wise less. Okay, student. So D orbital is not that strong in forming pi bond. Okay, then fine. Then we'll disperse here, right? We'll do next time now. Fine. Okay, then bye. Bye.